Okay, part A, the answer for the unknown A is 10. The unknown for B is 0. Just simple substitution. Who got both of these correct? Raise your hand. Who got both correct? Fadila, you get it correct? Or haven't do it? Put your hands. Stay with the class, follow the pace. Now, the next part is to plot the graph. You have 10 minutes to plot this graph. 10 minutes to plot. Okay, the scale, the scales are the same. 2 cm 1 unit on the x-axis, 1 cm 1 unit on the y-axis. Plot the graph. Let's continue to answer the questions. Part C, draw the line of symmetry. Okay, now class, you were told to draw the graph from -3 until 3 only, right? Now if you are not given this range, they say just draw, then your graph will continue to go upwards this way, you'll continue to go upwards this way, yes? Does this make sense to you? It's a smooth curve, right? Now is this parabola symmetrical? Does it have a line of symmetry? Yes or no? Where is the line of symmetry? Is it a vertical line or a horizontal line or a diagonal line? Do you understand my question? Okay, so line of symmetry, vertical, horizontal or diagonal? Vertical, good. Where is the line of symmetry? It is here, right? This line that was drawn. Okay, so I'm going to highlight. Alright, you can't see yellow. Okay, this is the line of symmetry. Okay, how do we describe this line in mathematics? How do we describe this line? It has an equation. What is the equation of this line? I heard equals to. So what equals to what? For this vertical line? A. X equals to 0.5. Where did we get 0.5 from? From here. This cuts through 0.5. Look at your graph. Identify where is the x equals to 0.5. Once you have found it, draw a vertical line and label it as x equals to 0.5. Okay, as such over here. X equals to 0.5. Must you extend the graph? Yeah, you have to draw the graph for your limits for your x and y axis. So for example, if your x-axis is from -3 to 3, your graph must range from -3 to 3. If your y-axis ranges, in this case, from 12 to -4, then your vertical line must be from 12 to -4. Understand? Okay. So you should have 2 graphs on your graph paper for now. Okay? Are both your graphs labeled? I know I just told you to label your vertical line, which is x equals to 0.5. Have you also labeled your curve? What is the equation of the curve? Y equals to x squared minus x minus 2. So you must write that down near your curve. Okay, next. Find the coordinates of the minimum point. What does minimum point mean? This graph has many points, but there is only one minimum point. It must be found at the lowest point, the minimum point. So here, all of you should have the same. This is your minimum point, the lowest. And write down the coordinates. So the coordinates will be 0.5, comma, then you read off your graph. Okay, this is -2.3. So -2.3. Okay, so according to this graph that the teacher drew, the minimum point is 0.5, comma, negative 2.3. Did anybody get a different answer, but it is quite close? For example, negative 2.2, negative 2.4. Anybody? Anybody? There should be lah. Okay, because it is you are not computers. We don't expect you to be able to plot exactly the correct graph. So we will allow a bit of leeway. Understand what I'm saying? So if your answer for the y coordinate is negative 2.2, it is negative 2.4, we will also accept. But it cannot be too exaggerated. So here is where I want to tell you a trick that I use as a student. You know, when you are told to find a minimum point, actually there is a fixed answer, right? But just that your graph may not reflect the correct answer. So what is one way we can do to ensure our answer will definitely be correct? What is one thing that we can do to ensure that this value, negative 2.3, is definitely correct? Is there a way to find the exact position of the point when x equals to 0.5? Can, right? Shashan, what can we do? Substitute what into what? Yeah, substitute 0.5 into x into the equation, right? Can all of you try that right now? Put 0.5 into the original equation of y equals to x squared minus x minus 2. What does your calculator tell you? Negative 2.25. Okay? So that is the exact answer. So when your graph returns you a value of negative 2.3, you know that, oh, you're very safe. You are very close to it already. Okay? So you leave it like this. Then if somebody writes down the value of here, negative 2.25, then I know this person is not reading the value of the graph. This person is actually using a calculator. You know how I know? Because I cannot get 2.25, negative 2.25 from the graph. Why is that so? Let's look at the smallest square possible. So from this is negative 2. This is negative 3. What is the spacing over here for one small square, the height of the one small square? 0.2. Okay, so this is 0.2. 0.2, 0.4, 0.6, 0.8, then 1 unit, right? Are you able to read with your eyes very accurately half of a square? Or rather less than half of a square? It's not possible. In mathematics, in physics, in chemistry, for your O-level syllabus, we only allow you to read up to half of a small square. So in this case, the minimum point lies here, right? So we draw a dotted line across, it cuts at this point. Now, does this lie nicely on 0.2? Does it lie very nicely on negative 2.2? No, it doesn't. Does it lie on negative 2.4? No, it doesn't. It lies in between, right? If it lies in between, there is only one answer. That is negative 2.3. You cannot come and tell me that it is negative 2.25. Do you understand what I'm saying? We can only read up to half of a small square. Nothing more. Okay? So this answer over here, we will write as negative 2.3. But deep down, we know that the exact answer should have been negative 2.25 if we use a calculator. Understand? Okay. With that, let us continue. We have written down the minimum point already. From your graph, estimate the y value when x is negative 2.5. So go to your graph. X is negative 2.5. Okay, identify where is your x equals to negative 2.5. So on my x-axis, x is negative 2.5 over here. This is negative 2.5. So draw a dotted line up. Up. until you touch your graph over here in this case. For different students, you will have slightly different answers, which we will accept if it is close enough. So according to this graph that was drawn, we draw a dotted line across again, and we intersect the y-axis. Then we write down the value. In this example I have, this dotted line cuts at this point. So since 5 small squares represent 1 unit, 1 small square represents 0.2, so this is 6.2, 6.4, 6.6. Between 6.6 and 6.8 must be 6.7, nothing else. So we indicate this is 6.7, and this is for question E part 1. So label E part 1, 6.7. So the next part of the question wants x values when y equals to 3. So in your graph, where is the line y equals to 3? Is it a horizontal or vertical line? Y equals to 3. Horizontal or vertical? Y equals to 3. Y equals to 3 is here. It is a horizontal line. So draw a dotted line all the way across. Okay, like this. Dotted line, y equals to 3. So this dotted line again will cut your graph at 2 points over here. So drop another dotted line down. Here I've got negative 1.8 as well as 2.8. Check your answer. Are they close? Flip to page 3. I want you to highlight this word. Oh yeah, you can't see. You see x squared appearing. Right? You see the x squared appearing. So now we are going to learn what is the shape of these graphs like. What are the shapes of these graphs like? So should we take out a graph paper and start plotting all of them? What is the better way? Go online? Okay, let's go online. Of y equals to x squared. What do you notice about this graph? Very thin, very narrow, is it? Okay, what else can you tell me about this graph? Is the U shape good? What else? It doesn't what? Doesn't cut the x-axis, are you sure? Where is the x-axis? You mean it doesn't intersect? Oh, but does it touch the x-axis? Yes, it touches the x-axis over here. Anything else? It is symmetrical. What is the line of symmetry? Y-axis, good. What is the equation of the y-axis? Y equals to 0 is not the y-axis. Y equals to 0 is this line. X equals to 0 is our y-axis. Okay? Because this is x equals to 5. This is x equals to 4, x equals to 3, x equals to 2, x equals to 1. This is x equals to 0. Okay? So these are some things that we can tell from the graph, this parabola y equals to x squared. So since you all say it is symmetrical, for example at this point, when x equals to 1, y over here, it looks like it's equal to 1. Okay? So on the other side, what must this value of x be? Negative 1, because it is symmetrical. Okay? Let's talk about this point over here. This is x equals to, what is this one? X equals to what? 3. So when x equals to 3, what is the value of y? 9. So we draw a line across 9. Does it intersect the curve again? Then you drop it down. What would this value be? Negative 3, right? So negative 3 is symmetrical to the, you put a mirror over here. Here we have 3 units. Here we also have 3 units. So negative 3 and 3. Get it? So that is our symmetrical property. So now draw in your... Okay, I don't want you to draw in the graph yet. Now we also require y equals to 2x squared in our graph. So what do you think the graph of y equals to 2x squared will look like? Will it also be a parabola? Yes, it will be. Do you think you will get exactly the same shape? Exactly the same graph? No. How do you think it will change? What do you mean by bigger? You mean it'll be wider or narrower? Wider? Do you have a reason to say it is wider? Because it is 2x. Okay, let's see. Y equals to 2x squared. So in blue, is the graph y equals to 2x squared. Is it wider or narrower? It is narrower. Why? Why? What do you mean one is smaller than the other? Let us consider when x equals to 1. Just consider when x equals to 1, for the red graph, y equals to x squared. When x equals to 1, what is the value of y? 1 times 1 is? 1. So for red color, we get 1, isn't it? Okay? For the same x value of 1, for the blue graph, 2x squared. So 2 times 1 times 2 times 1 squared, isn't it? So 2 times 1 times 1 is? Thank you very much. So the answer is? 2. When x equals to 1, y equals to 2. And that makes it narrower. Get it? Now, do these two graphs are these two graphs also symmetrical about the y-axis? Yes, they are. Do they have the same like U shape? Yes. Do they have a minimum point? Yes. Okay, good. Now I think you're all smart people. Can you guess what the graph of y equals to 3x squared like? Even narrower. Yes, okay, let's see. Y equals to 3x squared. Okay, so you are right. You can't really tell the difference in color, but it is narrower. Now, can you sketch? I say sketch, on your graph, or your notes, the shape of the parabola. For the first one, y equals to x squared, it is quite wide. Okay, try to draw it symmetrical. Okay, then it gets narrower, and it gets narrower. So these are your shapes of the parabola. Then on the other column, they say maximum / minimum point. What do you think is the answer? What do you think you should fill up? Max or min? Minimum point, okay? Why is it minimum? It is of this shape, right? This U shape. So there is a minimum point. Is there a maximum point? Yes or no? Let's look at the graph. Is there a maximum point? What do you think is the highest value? Yeah, it's actually infinite. It goes on and on forever and ever. Okay? Forever and ever. So there is no maximum point. You only have a minimum point. Do you like this shape of this parabola? Does it look natural to you? Have you seen this shape before? Where? Huh? What? What carrot? No lah, not carrot lah. Have you seen this shape before? In school? Okay, so look at your graph that you just finished plotting. What does it look like? Do you have a parabola also? Yes, is it symmetrical? Then good. Okay, we'll just complete this table and we'll stop here. Here we have 3 different equations. Y equals to negative x squared. Y equals to negative 2x squared. Y equals to negative 3x squared. What do you think the parabolas will be like? Inverted upside down. Huh? Okay, let's confirm with our graphing software. So the first one, I'm going to change it with a negative sign. Okay, so it flip over, and now it is at the bottom. It is below my x-axis. Okay? But it is still symmetrical. Does it have a minimum point right now? Does it have a minimum point? Don't have. Instead, it has a maximum point. Good. So, can you imagine what's going to happen to the blue graph when I put a minus sign? It will flip downwards. Will it be narrower? Yes, you are right. Okay, so it's more narrow. And of course, the third one also more narrow. Even narrower. And they all have a maximum point and they are all parabolas. So to fill them in, okay, last part, last bit already. What happens to the curve as the value of, okay, this one over here is modulus A, but you haven't learned it yet. Basically, they're asking you, ignore the minus sign, ignore all this. What happens as the coefficient without the negative sign becomes bigger? So instead of minus 3, it becomes minus 4, minus 5, minus 6. What happens to the shape of the graph? Narrower also. It becomes narrower. Okay? So that's all for the lesson.